Hi, good afternoon everyone. Welcome to another live stream. I'm hoping to kind of continue where I left off in my last session. So hopefully you may have already seen the recordings of that. Hey, Jay Miller is in the chat room. Good to see you, Jay. Jay is one of my colleagues over at Elastic on our DevRel team, so nice to see Jay. I'm assuming then that means my audio is coming through loud and clear, and I'm just going to also make sure I turn off the phone here. So high quality production, all of this at the moment. So yeah, we're going to kick off from where I left off. And in the last stream, what we were doing is playing around with JSON serialization, or deserialization specifically, actually. Looking at whether there's any optimizations we can make that might be stuff that we can bring into Elasticsearch.net. We're looking for the sort of the next major release to do a lot more code gen, and automated kind of source code based on all of the type information that we have for the Elasticsearch REST APIs. And one of the things that we're therefore thinking we might be able to do is, can we write some automated source generation that will build us JSON readers to read data from responses that we're getting from Elasticsearch, and can we do that any more efficiently than the built-in serializers? Given that we know a little bit more information about the shape of the models, can we take some shortcuts to optimize? So that's kind of where we're at. If I switch over to the code. So I won't go through this in great depth because we've covered it on previous streams, but the basic idea is we have a chunk of JSON which represents a response from Elasticsearch, and what we're then doing is we've got a number of benchmarks set up that use the UTF-8 JSON serializer, which is kind of what's in Elasticsearch.net today. We use that to deserialize. We also test with System Text JSON, the new Microsoft JSON serializer, and then we've got this custom reader, which is the thing that I built in the last stream, which was just kind of a random idea of, could we use the low-level reader from Microsoft to parse through the stream of JSON tokens and pull together the actual object that we want with as few allocations as possible. The short answer is yes, we kind of can. So this is the result of the custom reader compared to those other two benchmarks, and we can see that we've optimized, in fact, nearly all of the allocations away. So this now pretty much represents the bytes for the actual object that we're expecting. There's 4 bytes that I've still yet to track down. We might come to looking at that, but in this session I'm actually going to refactor a bunch of things anyway, so we'll see if that changes. In terms of deserialization time, these are all very low numbers, 2 point something microseconds for the custom reader and the UTF-8 JSON, slightly slower in System Text JSON. So we've got to a pretty good place, but I've taken some shortcuts that may need to be figured out. So one of the things I did in the first version of this kind of custom reader is basically counted my way through the tokens in order to figure out where I was in the JSON as it was coming through, and then used a bunch of conditions. I can scan down to them here. A bunch of conditions basically that says, if we're in position 2 or 4, then this is the value I expect to read out. So try and read out, for example here, we're trying to read out the enum. This approach works, assuming this structure of this JSON doesn't change. So if, for example, one of these isn't sent in the JSON, we could have problems, or if the order of these gets changed by the server. Now, for some request responses, we can probably kind of make some kind of gambles that things aren't going to change, because we know how the JSON's actually built on the server, and that may or may not change, and we could potentially do some sort of validation around that. But I do want to take this to a point where this can be a little bit more robust. So as an example, if, for example, I just strip out this property from the JSON for a second, and then if we come back over to my benchmark tests, which really just exercise the existing code, this one's not going to run at the moment because we've kind of got rid of Newtonsoft JSON, because it's by far slower. Although a very good serializer, it's not performance optimized. It's kind of feature optimized. And then if I run all my tests, we'll see what happens, just as a bit of an example here. So all I've done is removed one property from my JSON, and I'm surprised the others failed. Actually, I wasn't expecting them. Okay, that's fair enough. Yeah, so these two failed. These are the built-in serializers. These failed because we were expecting the property on the deserialized object, to be 10. It's 0, which is the default value. So these have deserialized an object. It's just that particular property isn't in the JSON. So these tests would rightly actually be passing if we weren't validating for that optional property. But you can see on my custom reader, and it's a little hard to see because of the size of the screen. Can I do a zoom in? There we go. So what we're actually seeing is we're actually getting a format exception, and this is because now we're reading based on token IDs. We're actually expecting a different type of value than is actually available in the property, because we're just counting tokens as we go through. So that's kind of not ideal. So I'd like to get to the point where we can be a little bit more robust in our handling of this kind of problem. So what I'm going to do is use a similar technique to what I've just done, and I'm actually going to copy this reader here, and I'm just going to create a new instance of it, or a new type reference of it, and let's call this 2, and this is going to be our new instance. And then what we're going to do is we'll set up another benchmark around this as well. And then I'm going to just tweak this. I don't want to lose the work in the original one. I want to actually kind of compare against that as well and see if I have any sort of gains or losses against what I had previously. So what I'm thinking of doing is, at the moment I have these kind of horrific looking definitions for essentially strings, but they're defined using a byte array and then stored in a static read-only span of byte. And what this means is when this kind of gets compiled together, the .NET compiler is clever enough to place this in such a way that it can avoid mem copies when pulling this data back out. So we're not allocating here, and we should have reasonable performance. So what I'm thinking is, can I do something whereby we read the property, the name of the property, and then we compare it against a known value that we could write in using this read-only span of approach, and then kind of use that as our method of determining what we serialize or deserialize. That's my thinking. Now at the moment these are obviously hand-coded, and that's a pain, and it will be a bit dull in this stream as I put some of these in. The basic idea in the future is this could be code generated, so we'll use either source generators or just some kind of code generation tool that we'll write. So I'm not too worried about the fact that this takes a lot of effort, because we could automate that away. And so I'm just going to copy one of these, and we'll just sort of let's deal with one kind of property at a time. So our first property here is cluster underscore name. So I'm going to define what that looks like by basically setting up the bytes. Now, as I say, you're going to have to bear with me on this particular stream, because I think there's going to be a chunk of this. I'm not going to bother automating it until I know how good this goes. So that's going to be cluster underscore name, and then I just need to make sure I get these right. And it's very easy when you're doing this by hand to make a mistake. But basically these are the bytes for each character of the property name that I'm expecting. So that's cluster name. They're defined as a byte array. And then what we can do is, as we're reading through, and we've already seen this technique in the last stream, if we want to look at the value of a string, or value of a token I should say, but without actually allocating a string or doing anything too heavy, we can use this kind of approach. Now, I've taken some shortcuts here which work because I'm using a memory stream. They would not necessarily work with a stream of bytes coming in over from HTTP client. So I'm going to take shortcuts now, and then, if this proves to be a valid approach, then this needs to be a bit more robustly coded, because what we're saying is we're cheating here and assuming that we're always going to have everything kind of pre-read into the token. It's possible when the stream's coming in chunks that we'll have multiple buffers behind the scenes involved in storing those. And so that could end up with a sequence, which is where we have two buffers that kind of to combine together form a full token. The token kind of straddles those two chunks of data. And so in those cases, we actually need to read through a value sequence properly. Here I'm just cheating and taking the first part of it because I know I've got all the data in memory. So don't worry about the detail of that. That's a little bit low level, and I just want to kind of take the same approach for now. So what I'm going to say up in my new code, let's think about this. So we're going to read some bytes with them processing. So actually we can do this in the process method. What I'm going to add is, instead of a token counter, we're going to end up with a I wonder if we're going to end up with a property counter. Let's go with that concept at the moment. So we'll have a property counter, which means we can count which actual property we're going to be on. I might not stick with that, but we'll see. So what we're going to do is, in this block of code here, we are reading a property name, or in this case we're just kind of ignoring it, but now we're going to actually need to use the values. So what I'm going to say is the working span is going to be the same as what we did before. So this should represent a read-only span of byte that represents the bytes that make up the property name, so the UTF-8 bytes. So now I know what the working span is, and again this is a bit hacky, so needs to be robust for sequences. Let's add a to-do there. We've got the span, so what we could do is say working span dot sequence equal, and then we can do cluster name, which is our actual set of bytes. So if the working span is sequence equal to that, then what we could say here is our property counter then is property number 1. Now I don't actually know, is cluster name our real first property? It's not really. So it doesn't really matter, we just need some way of identifying the properties. We probably here could just do it by position. Let's zero index, so let's say that this is number 3. And this is all, random code at the moment. It may or may not be a good idea. Do feel free to comment in the chat if you've got concerns or better ideas. But let's say we know we're on property number 3. So what we can then do is, in this block of code, which is actually where we know we're looking at the value, we could actually now start switching on our property counter. And in this example then, what we're going to say is that the cluster name is, probably want to get rid of a bunch of these for now. Cluster name is actually number 3. I'm going to get rid of all these other cases, I think, for now. So what we're just saying is, if we're in or on property 3, then we'll try and set cluster name, which we arbitrarily know is number 3, by reading a string out. So that feels like that might work as an approach. Yeah, let's see where we're at. So the easiest way for us to validate this is to go into our tests and create, did I create another test for this? Not yet. So if I create a new test in here, which is our custom reader 2 test, this will be our custom reader 2 method, and we're going to assert on the response. Now this is going to fail if we get all of these. So let's just, for the time being, comment these out. We'll uncomment as we implement and make sure they're going to work. I think it's probably a way forward. So we'll run the test. So I'm expecting that I still get an instance. Well, that's not good. So cannot get the value of token type false as a string. So it looks like we've ended up in the wrong place. So let's go back to the code and see what we've done wrong. So so if it's position, or if it's token 0, we know that's the start of the object. This is going to also not be robust enough, so we'll probably get rid of this for now, because again, excuse me, what we're expecting is we don't know the position of that last counter, so we might need to do something a little bit more clever to kind of know when we're done. Is that going to cause us problems? Possibly. So we come into here on an even number. We're then we should, from our JSON. I can see the problem. I think I can see the problem. Yeah, we're not updating this. So before we start working out what that property counter is, we reset to 0. Now I 0 indexed in my mind. Let's say -1 is our starting point. And then when we set this value, when we initialize our object, we'll set that to -1. So -1 means we just haven't matched a property. We'll set that here, and then we'll go through our if statement, which will eventually grow to allow us to check against all the other possible properties. So maybe that works. Let's see what we're doing. Success. Oh, that's what I like. So it's a green test. So we have successfully read the cluster name. Now I don't know what the overhead of doing all this is, but I think for it to be reasonable, I'm going to basically have to stick with this now slightly arduous work of defining these arrays or these spans of bytes that represent each of the names. And you can kind of imagine how this might work in a generator. So imagine this is our type, which may also be source generated in some form, but it's got, here we're using the different attributes used by different JSON serializers, but we could have our own attribute, or we could just apply the data member and we could read in on the property. We could basically use reflection over this to see all of the properties, and for those properties we could identify them by a number in some form, look at the data member to get the name, and we could then potentially build in our reader the appropriate byte arrays for these. As I say, I'm just going to kind of hand do that for now. I'm tempted to maybe, let's say we'll try and do the first 4 of these, and then we'll run a benchmark, and we'll just see if we're onto a good track or not, like in terms of execution time, how heavy is that work, is it something we need to worry about before we continue going forward. So let's do active primary shards, and active shards percent as number, and then see how we get on, because that gives us 2 integers and a double, and then we can continue with the more complex types. How do we want to do this? We're just really going to be putting in these items up here now. It's going to be a little tricky for me. I'm on a horrifically large font size, so on the stream it comes out reasonably. I was hoping to try and stream this at 1080p today. It was telling me I was dropping frames when I did a quick test with that, so instead of dropping frames, I've kept with the lower res, which is a little blurry for you, I'm sure, but we'll kind of work on that as I do more streams. I'm going to work a good solution for doing this kind of stuff. The reason it's heavy on my machine is I'm doing all of this on one desktop, so I'm running Visual Studio, but I'm also running the Twitch Studio software that takes my screen share and encodes it and sends it up to Twitch. So there's a lot of processing going on, and that adds a load to my system, and I don't want to kill the machine entirely. So let's have a look here. So active _ primary _ shards. So I'm just going to do this again completely by hand. It isn't fun, but it's the easiest way to just quickly get going with a kind of proof of concept, and that's really all this is at the moment. This is a proof of concept. I'm starting to think about like what I want to bring to the Elasticsearch.net client in the next sort of few months to to even longer term in terms of features that we can get in. So that's kind of my objective at this stage, is just prototype a few ideas, see how they look. If this works out well, then one of the other streams will probably be us messing around with source generators perhaps. And that's not how you spell private, so oh no, it's primary, that is right. See, this is the problem. I'm already starting to forget what the name of these things are. So active underscore primary shards, and I'm going to call it that just so I don't forget. So let's pop that up here. Active, you see I'm missing an E here. You can see the risk of doing this by hand. Active underscore primary underscore, and then we'll just chuck in, I'll chuck it from this way actually, SHARDS. But yeah, that's kind of the idea for these streams really, is, if I've got stuff that's kind of prototypey and kind of interesting outside of the main client code, I can kind of do these kind of small proof of concepts on streams, and you can kind of see the thought process behind them and yell when I'm doing something silly. Right, we've got that definition. So let's do a check now. So we can say here, let's do an else if then, working span.sequence equal to active primary shards. Then we'll say our property counter in this instance with zero indexing is 0. Now that's going to annoy me that we've got these out of order, so let's do it this way. And we might need to see if we can optimize this kind of code as well. There's lots of conditionals and stuff in this code at the moment, so maybe we can take some cheats. Sequence equal, I believe, is pretty performance optimized already, in that the team have tried to, if it compares the first byte, then okay, that's Jay's just on his way off, so thanks for joining, Jay, albeit briefly. Good to see you. Yeah, so yeah, we're basically comparing these, and we'll see if these work. So we can do a case 0 in here then, which is basically, we said it's an integer, so it's basically this code here, but it's active primary shards. That's going to be, we may as well case these out. So while we're here, let's do case 1, which is good question, active shards, and then active shards percent as number, active shards, and then case 2 is active shards percent as number, and I think we said this was a double, so let's get int, no, get double, sorry, yeah. That's an actual, just check it's a double and not a long, yeah. So I've picked some horrific ones to do here, although I can cheat a little bit on producing these strings, so this is active shards, and so this one's fairly straightforward because I can just get rid of the primary and the other underscore there, active shards, and then this is my brain is not on it today, active shards percent as number. So this one's going to be a bit more interesting. So we've got active shards underscore BRCENT. How have I managed to copy these with a double? Let's just grab that again. Percent underscore as underscore number. It's almost guaranteed to get this wrong, just by doing it by hand. So we're going to stick to these first 4. If we can prove that works, we can at least, we've got something a little bit more realistic to put through our benchmarking. Rachmanian, terrible pronunciation. Yes, string literal generator might help. This is actually, yes, I did actually, I think, show it in the last stream, or I meant to. If I didn't, I had the page loaded up. So there is a nice kind of source generator library that allows you to kind of do this just by putting an attribute over your property with the string that you want, and then it will do the source generation to build this for you. The reason I'm not using it here for now is partly I didn't want to bring a library in for the time being, but also I'm probably going to end up doing what that code does by implementing my own source generator for this stuff at the moment, is my thinking. So we'll probably have a custom source generator that takes our strongly typed response and then builds this whole reader thing for us. So all of this could probably be source generated based on the knowledge of what's in that type that we're going to be building, because all of this I think is stuff that we can probably source generate somehow. That's my thinking. But yes, if that doesn't end up being the case, then it would probably save me a bit of time. I think I did play around with it, and I think I had a problem with the library compiling in my code, and I was probably just doing something wrong. I played around with it in something else. Right, percent underscore as underscore number. But this is the exact reason why something like a source generator is useful, because you don't really want to be hand rolling this kind of stuff. And this is, again, as a reminder, this is a prototype, and it's also extremely low level. For most jobs, the default serializers are going to do what you want them to do. Something like system text JSON or UTF-8 JSON, as long as your models are suitable. So there are some limitations. You can't have internal setters, I think, for system text JSON, that kind of stuff. But as long as your models and your types are compatible, then using those built-in optimized serializers, which are sort of generic for most scenarios, will probably be good. In cases like this where we're building a library and we want to see if we can get ultimate performance by really hand rolling this, well, not hand rolling, automating, but hand building this code will be a good idea. So let's put this one in, then we'll run the test and we'll see if we've got those properties right, and then we'll run a benchmark. So I swear I did this a moment ago, or did I think about doing it and then not? I think I thought about doing it and then not. Must have thought about not doing it. That's curious. Oh no, okay, so I did the cases here, I didn't do the cases here, that's fine. Slowly going mad. It's Monday, my brain's still kind of setting up, I think. So if the working span is active shards or active shards percent as number, we've got those, we're in those positions. We've now done our cases for those different positions. So optimistically, I reckon, well, it helps if I actually test the right cases in the right order. So these were just kind of randomly written in. So the ones we're actually expecting to work are the active primary shards, active shards, sorry, and active shards percent as number. So those are the ones that we're currently thinking should work because we've implemented them. And if I've got the values right, which I have, we have a success. Good. So let's compare a benchmark of these. We've got the benchmarks written, so I'll let all of these run actually, but let's be fair to them and give them a block of JSON that's let's just get rid of that for a minute. I'm going to redefine this here, and I'm just going to define the bits that I know we can actually deserialize, so that we're all kind of deserializing off of the same amount of JSON. And we're moderately close then on in terms of comparison. So that's our JSON response from the server. We're expecting all serializers to be able to handle that. We could just double check that, I suppose, by running all of the tests. There should be no reason why they won't, except my custom reader test. Okay, of course. So this one does fail, so we can't compare against that. Okay, that's a good point. Okay, let's plan B. Let's do our first test. We'll have to use the same amount of JSON because otherwise the custom reader entirely fails. But let's just test the custom readers against one another. Now this isn't super fair realistically. It's not really fair at all if I run this now. So the only thing I think we can get from running this, I'm just going to switch over to here and kick this off while I explain explain myself. Let's just check this kicks off. So this is our benchmark run. So we're just doing a .NET run on the console project. We're making sure we're in release mode for for benchmark.net to run properly, and that should kick off, and we should just see it going through the motions in a moment, which it is. So this isn't going to be a fair test in theory, because the original custom benchmark reader is reading all of the JSON. The new version is only reading 4 properties from it. The one thing we could tell from this test is if this new version is slower than the original version, or allocates more, then we have problems, because already we haven't yet fully implemented it, but already it would be worse. So I'm hoping this is at least as good as, if not better than this one. If it is, it feels like we might be on the right track. If it isn't, I might need to rethink this approach yet again. So I brought it up earlier, actually, ready to sort of show on stream. I've got this example here. So Martijn, who's my colleague on the clients team at Elastic, sort of put me on to thinking about how UTF-8 JSON does this. And when they're doing their deserializing, you can see that they're using this optimized approach where they generate this representation of the property names by converting them eventually to these long numbers and then storing that data and then switching based on it, I think. So this is kind of what we're doing. We both want to avoid allocating the actual string to read the property name out, because that would be an allocation that's pretty heavy. So we don't want to convert the JSON token that we've read to a string to do a string comparison against something in order to be able to then just write the value out into a property. That's where the efficiency can be gained. This approach kind of tackles the problem, and it looks like they're using IL inlining as well, so there's going to be some stuff that maybe they can do in IL that we can't do in the C# code, and we may not be able to ever get as good as, in which case maybe we don't change, but they're taking an approach where they're trying to optimize a way to to be able to identify the properties and compare which property they're actually on using this technique. Our approach is, I guess, similar, but I've got a comment there, Newek, not sure what that refers to. Is it this? That's the owner of UTF-8 JSON, not sure. Yeah, not sure what the comment relates to, but do elaborate if you can. Yeah, so what I'm thinking is, is this going to work basically at this stage as a technique for us to be able to identify properties as we need to. So we've finished. Okay, so good thing is we haven't allocated anymore, so we've not added additional overhead. Now we might have a slightly larger DLL at the end of this because we're sticking all of this stuff as kind of predefined static read-only spans. I'm not sure what that impact will be, so we might need to assess that. And you can see we are, fractionally quicker than the original one. The key thing I wanted to avoid is getting slower, so I guess we are probably on a good track so far. So I'm going to plow on with this plan to see if I can get this whole type to deserialize, and I think that's probably all I'm going to get to today. So let's carry on till we hit some of the interesting stuff again, like the enum. So we've already done cluster names, so let's do delayed unassigned shards and then initializing shards. I should probably write this down. Unassigned underscore shards, Initializing. I'd normally drag all of this out to a separate screen, but I want everyone to see the same screens that I'm seeing ideally. And then maybe we do number of data nodes. I mean, all of these are going to be done at some stage. Delayed unassigned shards, that's where we're going to go first. Actually, I copied that, but I won't really need that. So again, it's more defining of these. The more I do it, the more I'm thinking it probably would have been a good chance to play with the string literal generator, but well, we're here now. I think I don't want to. I'd rather just get to the point where I know this does or doesn't work, and then worry about optimizing and considering how we actually approach it in a future stream. Because I think that will kind of be one of the next steps, is maybe to try and write our own source generator, which I've not done yet. I've been kind of interested in having the opportunity to do it, but never got around to actually having a real case for it. So that's where I'm kind of heading, and this is, you know, as much about learning and playing as it is just kind of, you know, progressing with the code that I actually need. Tra-la-la, unassigned shards. So that's that one. The next one was initializing shards. All of this information, if you're interested in where this is coming from, is basically cluster state in Elasticsearch. So I have to make sure I spell this with the American spelling. So yeah, this is, you know, this API which I've picked just randomly, almost just because it was kind of a simple kind of request or response, I should say, to actually model. Just represents the health of a cluster. So, you know, cluster is a group of well, one or more nodes in your Elasticsearch, you know, running Elasticsearch, and they're operating together in a cluster to give you sort of high availability and resiliency. And so this API gives you the health back of that cluster, and then the shards are kind of how your indices are broken up by Elasticsearch. Depending on how you configure Elasticsearch to run, you might have one shard per index, or you might have many. So this information, you know, can give you information about that, but also, you know, are shards initializing? Are they trying to be assigned somewhere to one of the nodes in the cluster? That kind of information. And, you know, if that's temporary, it's usually good. It's fine. It's, you know, you maybe have added an index, or you're doing some kind of operation where you expect that. But if it's struggling, then you'd want to find that out from the health. And the key indicator will be, are we in red, green, or yellow state, really? So red is generally going to be pretty bad. You know, the cluster can't get to a state where it considers itself reasonably good. Yellow means, okay, it's going to be functional, but you might not have, say, all your replicas that you've configured necessarily assigned in the right places yet. And then green just kind of means that all of your requirements for your, you know, your indexes are met. I should try and stop talking while I do this, because this is actually quite hard to do this manually. So this is initializing. What do we end up with? Just shards, yeah. So this is an underscore, and I've already got shards written, hopefully, in here. Initializing shards, so we've got number of data nodes. This is realistically not a great way to have gone about doing this as a proof of concept. So kind of under anticipated quite how slow I'd be at just putting together these bytes, but it's fine. It's a test. It's a prototype. I don't really want to overcomplicate it until I know it does something useful. Oops, underscore data. if you've stuck with me in the chat room, well done so far, because this is, you know, it's boring to do. It's probably equally boring to watch. As I say, I'm hoping fairly soon when I can get through this. If I missed an S on the end there, then we'll get to the, you know, the more interesting stuff in a future stream as well. You're basically just watching me prototyping code here at the minute. So what else have we got? Number of data nodes we've done. So number of in-flight fetch. Number of nodes. Number of pending tasks. We are getting there. We're not doing too bad. Number of data nodes. Number of in-flight fetch. Number of in flight oops, come on, Visual Studio, and then that's an underscore, and then we end up with fetch, F-E-T-C-H. So we end the next one we said was number of nodes, so that's actually a little easier. Number of, and that's just N O T E S. I'll get rid of all of those. Number of nodes. What else we got? Number of pending tasks. So I'm going to copy from that one because it's going to be a little bit longer, so may as well use that. Ooh. Pending tasks. Number of P. Pending underscore, and then that's actually TA. Conveniently not too bad. Number of pending tasks. Getting close. Let's just keep going. What we got left? 4 to do. 5 to do. Need a piece of paper, so I've got that large. So we've done a number of pending tasks. I'll be very surprised if I get all of these right immediately. We'll find out shortly. Status, which should be a nice easy one. Task max, this is a horrible one. Waiting in underscore queue underscore minis. And then timed out, it's nice and short, and unassigned shards. We can probably steal the, I think we had an assigned shards or something, didn't we? So we can probably just steal that and tweak it a little bit. Do we don't have assigned shards, do we? No, we have initializing shards. It's probably going to be the closest to it. We'll see when we get there. Let's do relocating shards. So I'm going to use this one. Just picking ones that I know I've got already close to what I want in bytes for now. So this is relocating shards. Oops. Okay. And then, oops, and then it's to underscore. Do I give it? I've already got the underscore. Underscore shards. Status is a really short one. Should have saved this to the end because it's the least painful to do. So as I say, this has all got to be stored somewhere in the DLL. So I'm kind of wondering, you know, how much I have to worry about that. Let's do the horrendous one. So let's pick the longest we've got so far. But so it gives us that advantage that you know, we might be able to do some cheats as well. So you know, perhaps when we're analysing these, we could look for the kind of a bit like you would with a Git chart, really. The or the Docker container ID is actually a really good example where, you know, you get down to the smallest possible set of bytes that represent a unique part of the token, and perhaps we could use that. So, you know, obviously these all begin with number, so we couldn't use just number to define them, but maybe we could do number of, and then the first letter would be probably enough, number of in nodes p, so they're all different. So we could say, well, we define the start of the item to the point where we get to the most specific, or they're all unique at least, and then I can't remember if there's a sequence equal equivalent with sort of starts as or sequence starts with or something. We can have a look at that. That might be a way of reducing, you know, it would be a way of reducing manual work, but even you know, overhead on terms of defining all of these could be avoided perhaps. And perhaps, you know, the UTF-8 JSON approach of actually, you know, taking the bytes, converting them essentially to a long and using that as the way of distinguishing things could work, although I wasn't, you know, entirely clear if I could just reuse that approach and get the same kind of gains here. Probably could, but you just need to maintain that lookup. So we'll see. It's all stuff we can kind of play with. It's kind of the approach is really try the smallest changes possible, compare how they go with a benchmark, and then kind of go from there, really. Let's pull this across. This is starting to get very hard to follow on my screen. But yeah, all kind of valid approaches, I would say. I'm not convinced, you know, which is better off the top of my head, and that's kind of why we use benchmarks to prove or disprove a good approach, and then kind of keep going until it's as good as it can be, while also being, you know, moderately nice code. But again, if this is auto generated type code, I'm not too worried if it's ugly-ish, as long as, you know, from a usability perspective on the public API end that it works efficiently. That's what you kind of want. It's not Q. So because I'm talking while I'm doing this, I'm fairly sure at some point I've screwed one of these up, and we'll find that out in the test and then go and fix it. So I need a few more letters. L-I, no double L, I-S. We're nearly there. Timed out. T-I-M-E-D. Let's go. I-E-T. And then the last one is unassigned shards, so I probably do want one that ends in the word shards. Probably that one's a good one. And this is unassigned shards, and it's unassigned. if you're just joined us, you'd be totally reasonable in wondering what the heck I'm doing. Basically, at the moment, hand rolling some read-only span and bytes that we're going to use for comparison purposes. So in theory, I've done that. So now we need to update our code here. We can just figure out based on sequence equal where we're at. So again, I need to kind of know the position in order. I'm just going to, for my own sanity, copy this out into Notepad++ and just put it over on this other monitor because I think it'll save me jumping back and forward. So that one's the one after cluster name. Cool. So what we're saying is we'd end up with 5, 6. So after cluster name comes delayed unassigned shards, initializing shards, number of data nodes, check these in here, number of data nodes, number of in-flight fetch, number of nodes overall, pending task, pending tasks, relocating shards. Just to make these numbers before I forget. Again, this is still relatively brittle in the sense that it's very easy to make it wrong, but you could see how this could be code generated and automated just by going through the properties that are on this type. So relocating stars status, task max, waiting, timed out, and then the last one up I need is unassigned shards. And then that's 11, 12, 13, and 14. So in theory, that identifies all of our properties. So once we've read into there, we know what property we're on. So yeah, we just need to update these cases now. Well, the next one's an int, so I'm just going to use these for now. Probably would have helped if my first definition I'd defined these in the right order. I could probably have just, that's an int. Number 4, so then initializing shards is number 5. Number 6 is number of data nodes, number of in-flight fetch is next. Those are all integers. Oh, hang on, I've got these the wrong way around. Number of data, there you go, so this is already, that's number of data nodes. All right, number of in-flight fetch, and then number of nodes. That's number 8. Number of pending tasks, then relocating shards. Pending tasks. Shard, let's use a word that's unique. Relocate shards. Right, now we're into the health status, which basically we're going to use this case from previous. This was the code that basically knows how to take the token value, which will represent whatever is in text, and then convert it over to our enum. And you can imagine that this would probably be something that would have to be generated as a kind of reader for the enum, perhaps, so that this code isn't coded everywhere into all of our using types. But we'll see. So we've got that for status. Then we've got a long, a bool, and an int. So I may as well do the long next, which goes to task max waiting time in milliseconds. This is 64, so it's a long. Then the bool, well, we've already got code for that here, so let's reuse that as number 13. We previously did a check. We're kind of getting rid of these checks because actually the methods from get whatever will throw if it's not valid anyway, so it kind of, we don't want to waste a check that's going to be repeated. I can get rid of all of this now. And then just put in the last int based case, so I'll steal this one. Case 14, which goes to unassigned shards. Okay, so may or may not have done this correctly. Almost certainly I've screwed something up somewhere. Let's clear some of this up a bit. Yeah, so we're not. I mean, we could probably exit early if we get to the end token, but it's not necessarily going to be at a certain position. So we'll think about short-circuiting the exit in a moment. So what we can say is if we reach an end token, actually, yeah, we do want to exit out of this because otherwise, yes, if a token's missing, then we're not going to have a property. So let's have I think we'll just stick it up here for now. So we'll say if reader.token token type is equal to JSON.endObject, then let's just break from this loop and we'll stop reading. We probably want some kind of state to track we've done this, so let's just do done so we've got our done there. We'll set done here. Yeah. So we do that. I'm going to leave this check in because that's pretty reasonable. Let me check we've actually got a start object. And then if we're done, when we've come out of process, might as well just make it a case up here. So last read bytes equals read stream and not done. Oh, get this conditionals right, and not done. Then we'll keep looping. Feels like that might work. We'll see. Is that because I commented those out, isn't it? So let's get rid of these tests for a second. We're only really caring about these two, and then we'll just uncomment all of this and see how wrong I got it. So now we're expecting this last test to actually pass. It's probably not going to. Yeah. So we expected the status to be yellow, but we found green. So that looks like we didn't count our way in properly, or there's something else going on this code. So I may end up debugging into this to be able to track this down. Did I set the status? So we said number 10 is status. Let me just see my, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's wrong then, isn't it? So 11, 12, 13, 14. We should have 14 and we've not got 14. So I've definitely, oh no, we do have 14. For some reason, oh, excuse me, case 11. So that's right. Yeah, sorry. Yeah, so if it's equal to status, property count should be 11. And then we get in here. So that's interesting. So let's chuck a breakpoint there. Chuck a breakpoint here. In all likelihood, before we do this, I've just messed up the word status. S-T, I have. Status is spelt status. This is why we have a unit test around it, to make sure I'm not messing obvious things up. Okay, we expect Untitled Shards to be 7, but it's not. Again, I'm probably expecting that's most likely a typo in here. Unassigned underscore shards. That looks good, I think. Unassigned shards. Unassigned shards is the last item, so that's number 14. We set it here, so we're not going to need those. Might want these. We've compared it to that, so it looks like we're getting to here and we're not matching this assignment. So let's just double check this again. Unassigned. If you can see my typo or any suggestions, give a shout out, but it feels like that's correct. So let's just run this on debug and just see if we actually hit the conditional at all. So we failed here, but that means we did not hit our code here. But we've hit everything else. Let's just take this one out for a second. Just sanity check I'm vaguely close. No, we didn't get it right there because wait time in queue is also not, well, that's a very long one. So it's equally possible I've screwed that one up. That's that one there. So we've got through these assertions. Let's double check task wait time in queue milliseconds. Let me just check the full name of that. Task underscore max waiting in queue milliseconds. Task max waiting in queue milliseconds. That's defined up here. So that one's task underscore, is it max waiting in queue? Yeah. Waiting in queue. I don't think it has in. What's that? It doesn't. So that's my mistake there again. So again, just typo. Cool, we're passing, so this one's still not, but more closer. So we expect unassigned shards, which is on here, and it's unassigned shards. I'm just going to copy this string here. So we never hit this case, which is primarily because we never hit this case. Okay. So UN AWS ING ED. Oh, hang on. I can't really see the wood for the trees with these spans. Let's spell it correctly there. Right. So I looked at that 3 or 4 times. Could not see it, which is why that kind of code is, you know, not stuff you'd write by hand. Okay, we have a success. This, well, that should still pass because I've got the full JSON. Cool. So both of our approaches pass. So we're kind of at benchmark stage now. I'm just going to see how that performs. If this works, I'm kind of tempted to say that's where I'm going to get to today. In terms of we've got an approach that's then resilient to the fact that the JSON could come back in any, you know, the properties could be in any order. They could even be missing entirely. You know, we only care about reading what's actually present in the JSON. If it gives, you know, if we have one item in the JSON, we just check that, find out where it fits, and assign it. But I think, you know, this is definitely better than what we had from the last stream in terms of that kind of support. Again, this is all very ugly code that we would look to auto-generate, I think, fairly easily. The one piece of, or the one section of code, I guess, that we need to still look at would be this. It's yeah, it's a bit of a pain, but we can basically, I think, factor that out into a method that can read into a temporary, an additional temporary buffer that will just create off the array pool and then pull that back in. I think that feels like that would work. So just waiting on tests really now. Sorry, waiting on benchmarks now. Kind of, well, goal number one is make it as at least efficient as, I should have run this against system text JSON really actually, and probably UTF-8 JSON would have been good to put back in. I'll run that test later. You know, we want to make sure that we are better in terms of performance than what is in the box, or, you know, can be brought in as a library. There's very little point in all this effort if we can't improve. Now, I think we've already shown we can definitely reduce the number of allocations, because we are now down to essentially 0 allocations bar our actual object that we want. And I have some thoughts about those objects as well, which will be a future stream, about how we might be able to optimize by pooling some of those objects, you know, perhaps possibly as well, which you don't want to do for infrequently used responses, but maybe we can, you know, we can put some kind of measures in, and if we see a certain request is happening often, so therefore we have a certain response quite often, maybe we use an object pool to store those, and so we get the advantage of those just hanging around for a longer period of time, but also, you know, being reused. They'd have to be reused reasonably often for it to be worthwhile doing. It's an option I'm kind of considering. The overall intent of all this stuff is to say Elasticsearch.net is a library. People are bringing that into their code. We want it to be as efficient as possible for you out of the box. You know, you get all of these advantages in .NET today, where if you upgrade to .NET 5 from 3.1, you get a performance gain. If you were on 2.1 and you went to 3.1, you got a performance gain. Kind of want to try and follow that trend through into this library code as well, so that, you know, we aren't producing overhead. Okay, so we've got the same number of allocations in terms of bytes. I'm happy with that. That's kind of to be expected. I'll see this in a bit. We are a little slower than the first one, and that's because we are doing those sequence checks. So in the previous version, this first version here, we are just counting token numbers, and then we're using that to figure out where we are in the JSON that we've read, and then, you know, do the appropriate thing to assign the appropriate property. And that works as long as you can guarantee that the JSON always returns the same number of properties and always has them in the same order. Otherwise, it's extremely fragile. So you know, I think for the sake of 0.2 of a microsecond, I don't think that really matters. That overhead is not worth worrying about. I've still got this. So last time on the stream, I did some profiling, just rough profiling, and found out that it was actually 132 bytes represents the response object, so the response class, plus the string that gets allocated for it. And I could not see in those profiles where the additional 4 bytes is going. It's still being measured there. Not sure if that's a glitch in benchmark.net, or I've done something daft, which I tend to lean towards as my first possibility with these things, but I think we're there. So we've kind of, I think we've covered an hour here. We've got an improved, by improved I mean slightly less performant but much more robust version of our reader. You know, it has all these ugly things, but we could certainly generate those by reflecting over the types using something like a source generator and producing this kind of dumped output. Perhaps we can do something even cleverer and, you know, even look at IL emit type stuff. It's not stuff I've done in the past. I've never needed to go that low, but maybe we can admit that and get rid of this off of the type itself. But if this is a generated type, all of this logic would be therefore generated, and it's just it would be an internal type, I guess, that we'd probably use just for high performance deserialization. I think the fact that we are 136 bytes, I can't remember what the comparison was now, what we got to last time. It was 200 and something. So we've certainly shaved off nearly 100 bytes, I think, off of the process, which is pretty good. If you consider this is a very simple response, if you think of something more like a search response, which can be quite big, it's going to have an array of hits, and all those hits represent your your matched documents in Elasticsearch. So those kind of things can get quite big quite quickly. So if we could do those deserializations with low overhead, that would be good. But we would need to be in a position to generate that code, because we start to have a much more complex structure there, a much more complex structure of JSON to model. So my thinking is really that, probably the next step of this prototype would be, can I generate this from a source generator? And then if I can, maybe see if the source generator also works with a complex kind of type that has arrays, and it has optional arrays of objects and those kind of things, and can we actually get to the point where that would be realistic? And if it is, then we can look at kind of taking that forward. So that's it, I think, for this stream. Thank you for joining me again. These are a bit ad hoc at the moment. They're kind of as and when I have time to, at the end of the day, to kind of play around with these prototypes. I've got another prototype bubbling around in my head at the moment for looking at how we actually model the kind of fluent syntax for Nest, which is a very high level idea at the moment. I don't know whether it would be more efficient or not, whether it would be cleaner to read or easier to read, I don't know. But I'm keen to kind of play around with that while I'm thinking about all of these kind of generator type things, where we could generate types and we can generate them from a schema that we're producing, a JSON schema of what Elasticsearch APIs expose. We're going to look at generating the types, generating these kind of things like these readers. So there's lots of potential to kind of improve things where we can. Even if it means writing more code, it will be code that's written by a source generator or an automated class that kind of goes through all of this, or a console app basically that will go through this. So that, as I say, that's where I'm going to end it. Let's just do the right thing here and just add this all in. So I'm going to add both my files there. Those changes are good. Status. Cool, we've got those. And I'm going to commit these. Add more robust reader. Let's call it custom reader. And then we'll push that up. So that's going up to the GitHub repo. That's up on my GitHub. So that's up on Steve J. Gordon on GitHub, and there's a repository in there, JSON benchmarks, which is just updated. So this is open. If you want to go and pull this down and play around with it yourself, try and, if you can improve it, let me know. As I say, at some point this week, next, maybe we'll do a stream and start thinking about source generators, which I think will be really interesting for me to learn. And I don't expect to be getting it right first time, but we can play around with it, and we can just see what's possible with a source generator. Yeah, that's it. Thank you very much, and see you next time, hopefully.